right, we're on. Good afternoon, everyone. My name is Mike Torrey. I'm the COO here at Vertosa. I'll be your host for today's session. This is part two in our series on can liners and cannabis beverages. Our goal today is to look into can liner issues. We did that a little bit in the first session, but we're doing a little bit more on this one. Explore some interesting testing methods that Harold and Zach have been working on. And discuss, of course, the emulsion consistency and how they play with those liners. There is a Q&A box, so encourage you to submit your questions at any point throughout the talk. We'll try to address as many as we can at the end. But for now, I want to give our host, our panelists here a chance to introduce themselves. Of course, we have Harold Hahn, Dr. Harold Hahn, a good friend of mine, a colleague at Vertosa, and the happy chemist. So Harold, do you want to tell us a little bit about yourself?
Oh, thank you, Mike. Hi, everybody. This is Harold, an emulsion chemist, find his path into cannabis industry, and which turned out, we do need a good emulsion to power all those beautiful brands on the market. So emulsion chemist, understand emotions, but I find this path of joining Vertosa is for me to learn more about emotion. In this case, liner chemistry. So I want to share more today with you.
Thanks, Harold. And Zach, if you want to intro a little bit about yourself. Zach is the Vice President, Chief Operating Officer at Anresco Labs, a longtime partner of Vertosa, working on a lot more than just testing can liners, but certainly has been a hot topic for at least the last couple of years, but really since we've been around. So yeah, Zach, if you want to just say a little bit about yourself.
Sure. So I'm not a chemist and my background's in business, but my grandfather started our laboratory 82 years ago. So we've been involved in food testing for a long time. We've been performing cannabis and hemp testing for 9 or 10 years. And through osmosis, I've been able to absorb at least some of that. So looking forward to relaying that information today.
Cool. And just a little so that our participants here can know what to expect. Maybe each of you could give me a quick point on what you think you'd like people to take away from this session.
I think today we will talk about liners, right? And the methods to tell the liners. But I think to keep in mind, even you be able to tell the liner, that is a small part of the whole equation, right? Of talking about the maintaining stability of cannabis beverages. And there are many other steps that we have to pay attention to, which we'll share more in the slides.
Yeah, I'd concur with Harold's point that, can liners are extremely important, especially as it relates to scalping. But, the emulsion you use, the laboratory you use, how you store your samples, these all have effects on the storage and stability of your products and the consistency of the experience that your customers receive. So it's part of a larger picture that we're painting.
Great. So yeah, let's dig into it. And I know you guys have prepared some slides as I recall. So at any point, if you wanna pop them up, feel free. But yeah, I think what's important is understanding why cans and liners matter so much to creating a stable beverage. So I'll kick it to either one of you. Why is it important that we're looking at the can liners and talking about it so much?
I think it's interesting to remind us of the webinar one from last year. We had this webinar talk about the status of the liner industry with Anresco and DigiCan. And that webinar, we reviewed the complexity of the supply chain, right? And so as you know, what kind of complexity you see of cannabis beverage brands leveraging the can liners?
Yeah, definitely. Go ahead, Zach.
No, nothing to add on my part. I think we can proceed.
Yeah. I mean, what happens when somebody is ignoring this, that they don't think it matters? What are some of the risks there?
Scalping is definitely one of them, where the active attached to the liner and loose pollutants in the liquid. But also, I feel because our brands are starting, our industry may not have a calling and the power to buy cans at scale. So we get what we get, right? So usually the brands will hope and trust, and the liner is at high quality out for the right type, but usually they don't have a method to tell. So today, with the help with Anresco, we developed this method to tell you what liner you are actually using.
Yeah, I think there's also regulatory concerns. If many states now have implemented testing requirements for selling into them. And if you're not within a certain percentage of your label claims, then you don't have a passing or saleable product. And furthermore, if your customers are only getting 50% of the cannabinoids that they think they're purchasing, not only because maybe the emulsion contained the cannabinoids, but because they've been absorbed into the can liner, they're not getting the experience they're hoping for. So I think that's a danger to brands as well.
Yeah, I like that. I mean, I think at the end of the day, we're making these products for consumers, right? So if they're not getting what they expect, or if they're getting something different every time, we're not serving the consumer. And of course, we should be worried about that. I know retailers will be worried about that. Distributors will be worried about that. So everybody in the supply chain is ultimately serving the consumer. And if they're getting more than they bargained for, if they're getting less than they bargained for, we're not doing our job. So yeah, I appreciate that. Cool. Yeah, I mean, there's a lot of chemistry involved in this, and I am certainly not the expert on this, so we might have to let Harold talk for a little bit on this one. But I think it's important that we look at the chemistry, we understand why what is happening, the actual interactions here, and that'll lead us into a little bit more conversation with Zach of how can we test for the cannabinoids and how they're interacting.
Sure. I think it's time to share with everybody our discovery, our new method. So again, welcome everybody. It's the part 2 of the story. But before we get into the calendar testing method, I want to take a pause and show you the 7 main steps along the cannabis beverage supply chain that can potentially impact the potency of the product. It always starts with the cannabinoids. We all know cannabinoids, most of them are easy to oxidize. But when they are turning from the bulk ingredients into emulsion, and we dilute emulsion into the beverage concentration, they oxidize at different rates. For example, THC and THCV are the fastest to oxidize, followed by CBD and CBG, and then followed by CBC and CBN. So imagine if you make a THC beverages versus a CBN beverages, then you may have a different shelf life anticipation. Next step, infusion tech. None of the cannabinoids can go into water by themselves, so they all need a technology to transfer them into water-compatible ingredients. And this is where a company like Vertosa come in, and our job is to make sure we give our clients every batch a consistent output, right? In terms of the droplet size distribution, in terms of the stratification of the ingredients, in terms of the ingredients potency over the shelf life. Next step is beverage formulation. This is where most of the innovation come in. We have seen people using proteins, polyphenols, electrolytes. Well, some of the ingredients may cause issues for potency decay. One example is grapefruit juice. We often hear brands, and we have seen cases already. The grapefruit juice actually help accelerating scalping, right? So we're still finding out why this is happening, but we want to be careful about using different ingredients because they may introduce issues. Next step is the packaging. And this is where our topic is, but you see there is only belonging to one step along the whole supply chain. And can is one big factor, but there are other packaging like glass or PET, which have different issues or challenges compared to can. For example, PET, they allow oxygen to ingress all the time. So if the oxygen coming all the time, that may impact the stability of the cannabinoids. So we have to treat different packaging differently. Manufacture. This is the key step where everything got assembled. But how consistent they weigh each ingredients, how they introduce each ingredients, right? How high of a quality they are. It really matters. And another important factor is how much they can control the DO, the dissolved oxygen, right? We believe our cannabis beverage industry should leverage beer industry as a benchmark to control dissolved oxygen as low as possible. The next step is testing labs. We have one of the best testing labs here from Anresco, but working with testing labs can still be a challenge in terms of their integrity and consistency accuracy. So, I don't want to dive in too much on here, but it's a very important piece. So if you have all the 6 pieces figured out, you still haven't done the whole homework, which is the last piece is distribution and retail. This is where the product can be stored in the warehouse with high temperature, or you ship the product to Florida on a truck, which is not temperature controlled. So along this shipping time, you have a long duration of high temperature. This may not only impact our flavor, but impact our oxidation on the cannabinoids. So again, only when we look at all the 7 steps together, we can build in the confidence to remain the potency in the beverage.
Harold, I got a question. When you're looking at all 7 steps, is there kind of a hot spot or a problem child that typically points you back to the issue whether it's a flavor issue or a potency issue? Anything on this list of 7 that tends to be the recurring problem?
That's a great question. So always go back to the RCA, root cause analysis. When issue happens, when we go back, our team at least, we look at the 7 steps. So show us who produced it, what's the DO level, who tested, what kind of packaging you use, right? And then I think based on our experience, packaging is one of the main issue, and liner is one of the major issue about the packaging. I think that's why we're talking today.
Makes sense.
All right. So again, going back to the liner, a majority of our cannabis beverage is in a can, and I think everybody here are familiar with the concept called scalping, right? So let's dive into it. But before we talk more on scalping, I'd like to take a short moment to talk about liner manufacturers and can manufacturers. And sometimes I see our industry may confuse them together. So liner manufacturers, they produce the chemical called liner as a resin, right? So there are a couple of the main names are Sherwin-Williams, PPG, AkzoNobel, right? But the aluminum can manufacturers, their job is to take the liner material and they make the aluminum can while spraying the liner material into the can, right? So they produce the can. So some notable names including Ardog, Ball, Canpack, Kron, Emesys, Wobav, and Metal Container Corporation, or MCC. And so the relation between them are suppliers supplying their material to the manufacturers. But you can also see that there are more can manufacturers than liner manufacturers. I think one of the interesting reasons is when you talk about the liner, which is the chemical material in a can, it is very rare to find a chemical that is safe, that is cheap, that is stable with the liquid, right? So if you look at all the chemicals, there are only 2 or 3 couple of chemicals available for us. That's why there are more can manufacturers than liner companies. Then what are the major can liner types? So what we have seen so far, at least in the cannabis beverage industry, there are 3 main types. The first one is BPA, bisphenol A. This has a lot of issues, potential issues, I would say, because bisphenol A, this chemical, is endorphin, interrupting, so it can impact our hormones in the body. So, but also the argument is the amount from the liner released bisphenol A in the beverage is very low. But either way, California put Prop 65 so that if you use BPA in California, you should put a warning label of cancer. On the BPA, the brand name is usually called JB Weld epoxy, and our industry usually call this liner epoxy. The second liner type is BPA 9 in 10 or BPA NI. It is, the name tells everything. So it's not BPA, that's it. And then the brand name is Wall Pure. We commonly call it Ball Gen 2. But actually, Ball Gen 2 is not the accurate term to call it because it actually contains 3 different types of liners. They are Wallspar V70Q11, V70Q25, and V70Q38. And there are actually difference between them. As far as I know, 11, 38 are built for the can, 25 is built for the aluminum bottles. But there are nuances among their difference. And the third type of the liner is acrylic based. This includes Pro, which is a PPG liner called PPG 2012, and Alcolor, which we call them AkzoNobel G150. So there are 3 main liner types for our industry to leverage.
Harold, I got a question if you don't mind on that one. If we go back really quick. Yeah. So Ball Gen 2, this is something that has certainly confused me throughout the process because that is a very common term that I hear being thrown around. But noticing that it's Ball Gen 2, which on your last slide is a can manufacturer, but on this slide, we're talking about can liner types. Can these Valspar liners be integrated into other can types, or is that traditionally just used in ball cans?
Right. See, I'm a student also, but I was educated this way. So if you're a manufacturer of the can, you usually had a contract, a long-term contract with the liner companies. So the contract lasts for a long time, right? So Ball usually use Valspar. However, with innovation and supply issues globally, those contracts are becoming shorter, right? So can manufacturers can now actually leverage or change the liner suppliers more freely compared to before. So yes, it can be confused. So previously we called Ball Gen 2, which will imply for industry to know, okay, that is Valspar. But now I think with more iteration happening, I think it's really best to call the liner name by Valspar, by PPG 2012. That is the most accurate name.
Great, thank you.
Right. So scalping, right? We all know scalping is bad, and scalping allow inputs active stuck to the liner. But what does scalping look like in reality? So here is illustration that somebody argue scalping is because emulsion droplets, which is here, stuck to the liner, right? And another hypothesis is actually scalping is actually THC molecule stuck to the liner. So Mike and Zach, which hypothesis you think is really happening?
I'll let you go, Mike.
Yeah, this is a good question. I know that we're talking about the attraction of essentially hydrophobic and hydrophobic, or hydrophilic and hydrophilic. So the emulsion droplet is intended to be, water compatible. I'm gonna go with B because it's oil on oil. And I swear Harold and I have not talked about this if I'm right, but I'm gonna guess that the THC is somehow escaping the emulsion droplet, as that picture indicates.
Right. Well, Mike, you and I, we agree on the hypothesis, even though we haven't talked before. But this is our hypothesis too. But the issue is, how the hell does THC escape from the droplets and stuck to the liner? And here is a hypothesis, right? So if you zoom into this area, so in emulsion, the oil phase, right, the THC active is actually not staying in the emulsion droplets at all times. It's actually bouncing in and out of the droplets at all the time, right? but this is high frequency coming out and coming in. So this phenomenon for emulsion is called partition equilibrium. So if this happened, well, if the droplets is close to the liner, and if the liner just happened to have a high affinity to THC, and if all this happened, then the THC molecule will stuck to the liner, right? So again, this is our hypothesis. We have some indirect proof, but again, we're open to seek, experts in here to give us, another opinion or data. We're open to discuss. So calendar wash, I think this is a really critical step to prove THC is on the liner, right? And thanks to Anresco team that they developed this calendar wash protocol that can reliably recover the lost cannabinoids. So this is what happens. Imagine you have a beverage, right, with THC in here. Over a shelf life, we have some scalping, right? THC get lost. And then if you send this to Anresco, they will first pour out all the liquid. And then they will wash this empty can with water. The reason to wash with water is because if you pour the liquid out of the product, you cannot ensure all the liquid is out. And you don't want to test the product liquid to confuse the results, right? So you rinse with water a couple times to ensure all the beverage product is out. And then you add a solvent, in this case, isonitrile. And you add nearly more than half of the volume, and you put the can on an angle, right, to let it sit for 12 hours, to let the isonitrile to soak up the can. And then you change the other angle, right? Let it soak up for another 12 hours. So in this way, you can pour out the isonitrile and test HPLC on that and see how many of the THC is actually in the solvent. So here is a real-world example. We have a client who started with 5 milligrams in a can. And then over time, they only tested 3.92 milligrams. So there's something happening. It could be scalping. And Anresco did this test. And then overall, at the end, they find out in the isonitrile, they find out this much of milligram over here. So if you add 0.98 to 3.92 milligram, you get 4.9 milligrams recovered. So almost all cannabinoids are recovered by this washing method. So this method tells us a couple of things. One, you can prove where does the cannabinoid go, right? Is that a scalping or is it oxidation, right? So that's one. Two, it actually indirectly proved our hypothesis. Is because if your emulsion attached to the liner, rinsed by water, we will likely bring it out, right? Because emulsion is water compatible. So only when you use organic solvents, you can soak it up and bring it out. That tells us it's the THC molecule stuck to the liner. Okay, so all this preparation is coming to these slides where we show the 3 different liners. How do they impact our potency stability? And this is a results summary that we tested Vertosa Organic 3 and Organic 4 formula. We use THC as the active, and we start around 20 milligram, start with 10 milligram per 12 ounce, and we test it in 3 different liners at room temperature, and we test at 3 months and 6 months. And you can see for both emulsions, the BPA liner and BPA-NI liners showed really good stability. However, for acrylic liners, for both of emulsions, they showed a very decent decay, right? Of almost 70% loss over 6 months. So from this results, we can see we can have a stable combination of using organic 3, organic 4 in BPA or BPA liners. But acrylic liner seems to have issues. So we are telling our clients and advising our clients, hey, if you can try to avoid acrylic liners. But here's the issue. By eye, you cannot tell, right? Those are how the liner looks like. So since we cannot tell the liner type apart, how can we build the confidence? here is where the meat of the presentation. We developed this new method with Anresco team. The method is called FTIR, Fourier Transform Infrared Spectroscopy. So this is how FTIR works. You have your sample right here, and you shine a energy, in this case, an infrared light, to the sample. And the sample will absorb part of the light energy, and then it will let the rest of energy pass. And then your machine will capture how much light has been absorbed. And the computer is analyzing and give you a spectrum. And this trained chemist can just look at the spectrum and take a guess of what kind of material that is. So, but why chemists can tell that? Here's a simple mechanism for FTIR. Each molecule will absorb a certain part of energy when the IR shines on them. However, different molecules will absorb different energies. So if you plot different molecules and different functional groups on this FTIR spectrum, you're expected to see they have different spectrums, right? We call it fingerprint. So over the decades, chemists, they accumulate all the knowledge. And this picture showing us that we know each functional group, where they are in terms of the IR spectrum, right? So that's why a chemist can just look at it and see, okay, this likely is going to be this chemical. Any questions, Mike and Zach? No? All right. So now I will introduce Zach to talk about the Anresco FTIR process.
Sure. So Anresco has an FTIR at our laboratory, and we've analyzed various different can liners, and we've basically developed a database. So what happens is as we get new samples in, we'll cut out a portion of the can, and then we'll place it on we'll wash off the can first, so that the correlation between the material is as clean as possible. And then we'll put it on the FTIR reader, and basically it'll correlate the results, the wavelengths that the spectrum readings that Harold was relaying earlier, to one of the cans that we had previously tested and in our database. And so, each can liner, there's a lot of similarities, but there's variability between them as well. So when we actually analyze a sample, we can correlate how close they are to each different profile in our database. So we won't analyze, it won't just, the system won't give us a single reading saying this is what the can liner is. It'll give us correlated values, and we'll use those correlated values to give you the best idea of what we think that can liner is. And usually it's a pretty clear winner. So in this case, we tested a product against 6 different liners, and one is correlated over 99. So I think that's the clear winner. And the correlated values go a lot lower, especially as you get to non-Valspar can liners in this case.
I want to double click on this. So the journey to get this spectrum stack up is actually pretty long. We got an inspiration by talking to our industry friends and reading reference. IR could potentially help with this. And then we went out to our packaging partners. This is a shout out to our packaging partners, including Ball, PPG, and other players. And they give us, their authentic liners. And then we were offering those liners to Anresco, and they are building the database. So in here, you can see Valspar Q7, V70, Q11, 25, 38. This is how they look like under IR. And if you see the pattern, you see 38 are looking different than 25 over this peak. And those are the base hypothesis that we can tell the IR differently, so that this new sample, which is an unknown sample from our clients, the software, which is compare, this looks like, I think this and this looks very similar, right? But the software will do a better job to tell you how similarity between the two samples.
Correct. The database is only as good as the inputs that you put into it.
I have a question that might be for either of you. Impressive work done here, certainly to kind of apply this FTIR method to can liners so we can understand, what folks are using. But why why is this test necessary, and what's happening out there where they don't already know? Where are they not receiving COAs, or do they not know, hey, I got this ball can and it's got this specific liner, and there's no tag on it? Like what is this? Why was this born?
Yeah, so we perform this test in for two different reasons. There's kind of reactive testing and there's proactive testing. Reactive testing, especially is when you onboard new customers, we'll find that they have an issue where we're not getting the cannabinoid results that they were expecting. And then we have our own kind of process for in performing those investigations. So first we'll assume there's maybe an analytical issue. We'll reanalyze the sample, maybe try a different extraction methodology. If we're getting consistent results, then and we think that they're accurate, then we might start undergoing additional investigations. The can liner rinse method that Harold mentioned earlier. So if we're finding all the additional cannabinoids in the can liner, then we know that's a can liner issue. If we are not finding the cannabinoids, then perhaps it's an emulsion or other issue. But let's say we find it all in the can liner. Oh, well, is it because the can liner is just not compatible with the product, or is it because the improper can liner was used? So that's when we would perform the FTIR analysis to confirm that the customer received the correct can liner, because there's been some instances where we've had customers that thought they ordered one can liner, and then we performed this analysis and we found out that they received a second liner, or their batch of can liners were a mixture of what they ordered and something else. And that goes to proactive testing. So now some of our customers, every time they order a batch of can liners, they'll send in a few cans to us to perform that analysis proactively, so they don't manufacture a batch that's not saleable. They'll make sure that they have the correct can and can liner and ahead of time, because if you have 50,000 cans, you don't want to manufacture a bunch of batches with them and have issues afterwards. But Harold, feel free to add to that if you like.
Yeah, I think that's where Zach said, proactively, but also finding the root cause analysis, right? Play both ends. But to Mike's point, why our industry need this more urgently? Because we're smaller, right, compared to established beverage industry. We're smaller, so we may not we cannot call ball to get truckloads of cans. Some brands can right now, but since that, and also our brands may not be on the production floor at all times. So they have to trust what the co-packers and what the suppliers told them. And also this can supply chain is kind of chaotic, right? So many times we try to ask, what is your spec sheets? But usually they don't get it, or they get the old spec sheets. So all this combined just build a lot of uncertainty in this area, right? So that's why I see so much value, especially when the client's holding this COA from Anresco, telling them you are 99% likely to be V70Q11. I think that information is super critical to make the right decision.
Wonderful. Yeah, do we have anything else to discuss here on the FTIR components, Zach, Harold? I want to make sure you have enough time to dwell on this if we need to, but again, appreciate you both working together to come up with this. I know I've seen it solve a lot of our clients' headaches, and it's really given us a lot of information, like you said, Zachary, on the reactive testing, so that I've seen people changing ingredients and really stressing out about oxidation control and all this stuff when at the end of the day, they, like you said, they thought they had a liner that was compatible and they didn't. So it's been helpful to a lot of folks I've seen already. I see a new slide here, Harold, if you want to talk about that.
Well, this is for Zach. For people who wants to do this testing, how do they reach out?
Well, I think my contact information might be included at the end of the presentation. If not, it's just Zach at Anresco.com, ZACH at Anresco.com. And it's, happy to help set people up with an account if they don't have one. Vertosa customers do get an automatic discount, but it's a pretty straightforward analysis and it's a pretty quick turnaround. And relative to the potential loss you could have, it seems pretty worthwhile to do some proactive testing. So that's my pitch, but yeah.
Right.
I do feel this $100 is well spent in terms of avoiding hundreds of thousands of dollars of loss.
Yeah. As they say, an ounce of prevention is worth a pound of cure, and $100 is certainly a lot less than if you added a couple zeros, which I think would be at risk with failed batches. So
exactly. And this is our contact info.
cool. Maybe we can keep that up for a little bit while we jump to Q&A. That sound good to you, Zach and Harold? Okay. Got a lot of good questions here. Thank you, everyone, for being engaged. I will start with a question from Lewis. He'd like to know if ATALT cans, previously via American Canning, now via Vulcan in Texas, has also been tested with similar analyses for, I assume, potency stability.
It hasn't been being on the FTIR database, but we're open to test them. That's not a problem.
Let's put that on the list.
All right.
Thank you, Lewis. We will note that. Michael Turner has asked, how much does coating weight of the can liner affect the scalping? And how do suppliers guarantee even coating despite using the correct liner?
Wow, that's a great question. So Mike, so IR only tells you what it is, right? But when can manufacturers, they make the can, when they spray the liners, their spray quality can vary and can vary from plant to plant. And but so it is a concern. We have been testing some thick liners and thin liners of the W70, and we haven't seen a big difference among the results. But also, when can manufacturers produce millions of cans per minute at that scale, their machinery, their quality is usually pretty top notch, right? So when we buy cans from those can manufacturers I showed in the list, so we have a pretty high confidence in their manufacturers. But when you are purchasing cans from outside of the country, from Asia, from EU, be careful, right? And ask the thickness and the evenness of the spray. And there are labs that they can do more study onto the evenness of the liners. So that is a really good question.
Great. I'll clump a few questions here. It seems like we have a lot of people interested and concerned about DO. So what we got here is what's the best way to keep DO out of the can? Related to that, does DO, is it one of the biggest factors affecting potency stability? And there was one more. Similarly, has there been any testing to see how much DO plays a factor? Or is it assumed that the effects of DO are independent of the liner? So out of those questions, it's how much of a factor is DO? And then what is the best way to keep it out of the can?
Zach, you want to take any?
Well, in Anresco, I don't believe we test for DO, dissolved oxygen, but Harold, you might have a better idea of what the ramifications of that might be. So I'll let you take it.
Yeah, thank you, Zach. So compared to alcohol, where the ethanol molecule is very inert, it doesn't oxidize, right? So that's why you can store a liquor in your basement for decades, not losing the alcohol content. But most of the cannabinoids, they are sensitive to oxidation. So they're always finding ways to get lost for potency. So today we talk about physical loss, which is attaching scalping to the liner. But a more important aspect is the chemical loss, right? By way of oxidation. So we strongly suggest our clients and partners to reduce the dissolved oxygen to as low as possible. We know that beer industry can lower their can below 50 ppb, right? And that should be a goal that our industry should reach over time. So yes, lower DO means better quality. At the same time, liners can also be affected by higher DO. And there is a threshold, I think is around 1.8 ppm, so 1800 ppb. So when the dissolved oxygen is above that level, it may actually impact the can liner quality, right? So the can companies actually suggest to at least keep the DO below 1.8 ppm. So everything is interconnected over here. I hope that answered that question.
Great. I think it hopefully helped. If not, again, the supports are there. Harold is always happy to hop on a call with anybody who has more questions. We'll take a few more here. Aisha asked, what about other packaging options outside of cans, and what are the options for aluminum packets? I know you touched on that a little bit earlier, but yeah, what do we know about other packaging types?
So you always go back to the two sources of losing potency, chemical and physical, right? So for any packaging, we look at this too. So for example, a PET bottle or aluminum bottle, when we do our study, we put our emulsion in there and we detect how much get lost over time in the liquid, and we can do a can and wash method to see how much it scalps to the liner. So those studies will tell us the physical side. The chemical side is the ingress oxygen. So there is a certain material like HDPE and PET, their body allow oxygen to come in, right? So we need to be careful and setting the shelf life in the reasonable range, or you can play with the chemistry, which is you can boost up the antioxidants in the beverage to battle the incoming oxygen. So again, it always come back to the two root cause: chemical oxidation and physical scalping.
And Harold did say the magic word of shelf life and stability testing. That's something that we have a capability of performing at Anresco. And in his slide deck, he was saying how he evaluated different emulsions for stability over time. It's generally a pretty good practice to do that with your finished products too, at least on your trial or initial run. So you know that maybe even if the emulsion is compatible for a longer period of time, and if you have the correct can liner, that the ingredients are not contributing to a increased degradation relative to your expectations. And that can be done via accelerated conditions using ICH compliant stability chambers, or you could do them in real-time conditions, refrigerated conditions. I know that Vertosa also has their own recommended protocol for that. So if that's an interest of anyone, especially a Vertosa customer, I'd recommend they reach out to them.
Spot on. Yeah, Debbie's question was, are there any accelerated conditions that can be used to predict shelf life? I think we're just touching on that a little bit, but any more comments on that, Harold?
This is a interesting question. For example, in Canada, I think they're using 40 degrees C as an accelerating temperature, and also that is used in Michigan. But I think in Canada, 1 day at 40 degrees equals to, don't call me right, maybe 3 days at room temperature. But in Michigan, 1 day equals to 2 days. So what is exactly right? Is it 1 day or 3 days or 2 days? So this actually have a lot of things to do with the packaging type. If you are testing a can versus a PET bottle, PET bottle may ingress more oxygen. So 40 degree of PET may lose potency quicker than the 40 degree of the can. So this is where more study needs to be done to build the baseline of this packaging, this chemistry of liquid. 40 degree indicates how long, right? But as a rule of thumb, for us to indicate, we take either 2 to 3 days as a acceleration rate from 40 degrees.
Yeah, and I don't recall what ICH is. They have their own correlation between temperature and how many days accelerated it becomes. But I think at the end of the day, there's not a lot of data in the marketplace. Generally, the way that you can determine a good correlation for your product is to run a parallel real-time study. And then after a few months, you can then compare the results of 1 month at accelerated versus maybe 3 months at real time and say that that's a fair correlation to use going forward. And so that's what a lot of our customers do.
Yeah. Another another factor is if you have a THC drink or a CBD drink, they oxidize at a different rate, right? So the equation should be developed against a certain cannabinoid type.
Leading right into my next question again. Well, not my question, Indu's question rather. Not related to oxidation, but do all cannabinoids behave similarly to scalping? For example, will CBD or CBN scalp at a different rate than THC?
Well, that's a great question. I hope we have the data, but I think over time, the scientists should build up that data. But on theory, they may not have the same scalping rate because the hydrophobicity may be different and the rate they coming in and out of the droplets may be different. So they may not have different scalping rate, but we're yet to find out.
Yeah, it's a great question. And we're seeing more and more multi-cannabinoid products on the marketplace. I probably should have some information on that to share, but I unfortunately do not.
Yeah.
But maybe for the next webinar.
Yeah, another great question for us to think about more back in the lab. Another one here, I assume, Zach, you might have some insight into this one, but with all these variables involved, I think that we saw the 7 steps of the supply chain that Harold presented, and there's subcategories with all of that. But with all of that considered, how do we approach hitting tight tolerances? Like Louisiana has a 5 milligram hard cap. What do you do to make sure you're going to get below that?
Yeah, I mean, that is challenging, especially when you're trying to sell into multiple states. So let's say Louisiana is a hard cap at 5, but then you also want to sell into another state, which is plus or minus 10%. And so you really only have a 5% variability in terms of what you can tolerate before you have a product that's not really saleable everywhere you're going to. I think the thing you need to do in those instances is just probably a lot of R&D and maybe to test the product as soon as possible. And I understand there's 7 steps, but if you work with Vertosa, then you could probably that's 2 steps that are kind of taken up right there. If you validate the can liner, that's another step. And if you use a laboratory that's consistent and you have a history of working with them and they get good recoveries on your products, then hopefully that's not something that should be a variable for every batch that you're producing. It's more so the initial method development or validation that might need to be performed on your specific SKU. So it is doable, but there's no getting around how challenging it might be.
I think it's the tight control, how tightly you can control the 7 steps. When I look at the 7 steps, each step may have their spec, right? Like this IR is setting the spec, like the dissolved oxygen we should set a spec for that. But also, who are the good operators among each step that who can, like Anresco, who can go to the lab and trust their data, right? I think that's where a brand should develop their tighten the spec for all the 7 steps.
Yeah, so developing your SOPs is extremely important, and oftentimes there's unanticipated challenges when you're developing a novel product. So that's where having good data comes into play. But once you have those SOPs, then you just have to follow it extremely strictly and hope that they're robust.
Cool. Running up on time, I'm going to do 2 more questions here. Harold, this one's interesting for you. Do we see a future where we might be designing emulsions that work better with an acrylic liner or designing things that are more compatible with what's out there in the market and available?
That's a great question. We have something in the work inside Vertosa R&D. We haven't fully launched the method. That is one type of thinking to how do we make acrylic liner work for our industry? But there could be other thoughts and other ideas that could facilitate the fortify the emulsion, right? Or make it stronger, make it less likely to scalp. So from what I see, I'm sure, I'm confident that when we come to the day that we have to use acrylic, we have a solution, but we don't have a commercial solution yet. But I think we have many smart people here to innovate.
A lot of great questions here. I'm loving all of these. So we might do another one if another one pops in. But Lewis just came up with one. Does the actual movement of the liquid in the cans in transit show a tangible increase in scalping? For example, if he's shipping the cans across country versus across town, is there a difference in how much will scalp?
Wow, that is a great question. I don't know. I think we should test it.
Yeah, you could probably have some kind of shaking test where you have it on a shaker for an extended period of time, and you can compare that to a sample that's not shaked and answer that question. But I unfortunately don't have a good answer for that yet.
Isn't there a saturation point?
So we have decent amount of data, but I say our data is still not the whole picture. If you talk about the profile of potency loss over time, right? So it usually hits a plateau over 5 to 10 weeks, and it depends on the emulsion and the liner combination. And if the liner and emulsion combination was bad, you may see a keep dropping, right? 20%, 30%, 70%. But if the liner and emulsion are compatible, you may see a 5 to 8% dip and then remains around below 8 to 7% over the whole shelf life. So we still need more data to look deeper into the profile.
Great. One more for you, Zach. This testing, the FTIR method, is this exclusive to Anresco?
Well, this is a method that we developed in partnership with Vertosa and the can liner manufacturers. I do not know if other labs offer this analysis. I haven't heard of it, but I wouldn't completely rule it out. But I would just note that Anresco, because of its long history and background in food testing, we do have a lot of capabilities like this that other labs do not, and can validate and develop methods like this, and other labs tend to have challenges with it. So the specific method that was discussed in this webinar might be exclusive to Anresco. Other labs might offer it, but I haven't heard of it.
Great, thank you. All right, almost up on time here. Any closing thoughts, Harold or Zach? Anything you feel like you haven't gotten off your chest yet?
Zach, anything?
Harold, I'm just happy that you let me coast along with you on this webinar. Appreciate you.
Well, thank you. We appreciate your collaboration too. I think these going back to the 7-step, it's the industry is tightening up our understanding and our operation, but I think this is just the starting. And look at beer, right? For how many years, how many research, how many budget put into the research, and we need those resources to put into the research and keep understanding it. So I advocate for more research and more funding for research, and we'll get there.
Great. Well, again, thank you everyone for attending, and all those who will be watching live, or sorry, watching not live. Just want to say, like Zach was saying earlier, with tight control, enough R&D, you can create a stable beverage. If not, feel free to reach out to us, and both Zach, Harold, myself, everybody is here to support. So thanks again. Y'all have a great day.
Thank you, everybody. Bye-bye.